Hey guys, we're back for day 2. I hope everybody enjoyed day 1's lesson. Again, they're recorded and put up, so if you're having trouble and you'd like to see it again, they're up there for your access. Today we're just going to look at forces and have a closer look at formulas, because if day 1 wasn't too effective, let's just, have the day 2 to be a little bit more specific, right? So we're going to take a closer look at formulas today and get introduced to another formula that we're going to use. All right, agenda, of course, criteria for success, some do now thoughts. We're going to take some notes because notes are always good. Execute some classwork and do our exit ticket, the exit ticket we all know and love so much. Criteria for success. Recognize what we have to solve for. We did some of that in the last class, but I want to keep emphasizing the importance of that. What formula do we even have to use in this word problem? Utilize the routine and show our work in an orderly way according to the routine. Do now. Read the word problem from yesterday. What words did I suggest for you to annotate and why? So at Six Flags, the nitro coaster's velocity goes from 0 meters per second at rest to 220 meters per second in 11 seconds. What is the coaster's acceleration? 7 seconds to take a look at that and make your decisions. Go ahead and deliberate. Great. So it wouldn't be velocity because they're just telling you what the velocity was. It would be acceleration because that's what we need to solve for. That's the formula that we need to use. So we would highlight that there. Acceleration, because we're looking at, it literally asks you a question. What's the coaster's acceleration? So you know we're looking for acceleration. We're going to highlight 0 meters per second at rest and 220 meters per second and 11 seconds. Why? Because 0 meters per second would be our initial velocity where we started at rest. And 220 meters per second will be our final velocity because that's what the velocity at which was traveled. And then, of course, we're going to circle or highlight whatever you decide to do 11 seconds because that's the time. So final velocity minus initial velocity over time is evidently the formula for acceleration. So we need all of those parts to fill in or substitute or take in place of in that formula. You see that there. Great. Look at here. We got to take some notes per usual, right? So here I kind of had it as them introducing each other. So let's look to the left. Speed. Hey, I'm the formula for speed. Distance and time are both measured to find me. I'm speed, right? And even here you see is speed equals distance divided by time. I don't want to use over time anymore because we're too deep into the lesson now. So we're going to use the word divided by. So speed divided by, speed equals distance divided by time. So distance is time is important here. But if we go over to velocity, we notice, Ms. Reed, it's the same thing. That's going to be so easy to remember and to do. Okay, great. It's me velocity. I know that they have a lot of speed and they have a lot in common, and they're the same. They look the same because the velocity also has to do with distance and time. But unlike him, speed, I have direction in my life. So don't ever forget to mention my direction in life, right? So on a previous question, it asked you about velocity in the last lesson. It talked about, I believe, going 200 and something meters west. That should be included in your answers. So if you've calculated distance to time and you're like, okay, I put the meters per second, Ms. Reed. Okay, but meters per second going in which direction? Velocity has to do with direction. So even if you're on, and like we said, on a nitro coaster, let's say you're sitting in the barrack in the seat and you're looking, let's say you're looking west. You're going, let's say, what's the speed? Let's say you're going 200. No, you're probably not going 200 miles per hour. I don't know. Maybe you're going 170 miles per hour west. So you have to include that direction there if you want to talk velocity. You want to talk velocity, you talk distance, time, and direction. You want to talk speed, you talk distance and time. All right? Great. Let's move down to acceleration. Sup, acceleration. My formula involves the starting or initial velocity. Remember when we talked about at rest? and the final or end velocity. Velocity is how fast you're going in a given direction. We just talked about that. Like 60 miles per hour east. Time is all a friend of all of hours. So if you see time here, you see time here, and you're also seeing time here. So time is universal with all of these formulas. Just tells you how long it is to take for an object to, excuse me, to change motion or to accelerate, right? So, quick recap, speed has to do with distance and time. Velocity has to do with distance, time, and direction. Whereas acceleration has a lot of going on. The velocity, initial velocity, the final velocity, and time. And we spoke about that in the previous lesson. I just wanted us to see how the formula has to do with the definition too, okay? And how these are measured. Because for speed is measured with distance and time, velocity is measured with distance, time, and direction, etc. So you can pause your screen to take these notes. I'm not gonna stop my lesson, so please take some notes, please. It would be really helpful to see it, hear it, like we do in class, but sometimes writing it helps you to remember as well, especially if you write it in your own way. This might look a mess to you, like it might be all over the place. Take the initiative to maybe even write a chart, put speed, put distance, time, then put the formula. Velocity, distance, time, direction, put the formula, acceleration, the two velocities, time, and then the formula, if that helps. Please and thank you. Now put this GIF here because I need you to remember and be hypnotized into remembering this routine chart. Finding your formula, writing your formula. Writing your equation by substituting those values in for those symbols, the D over T, whatever it is, and then giving an answer in units. Emphasis with units. I'm gonna say that every video. Emphasis with units. Don't just put 100. 100 what? $100? 100 people? No, 100 meters per second, whatever the case may be, all right? Just stare into that for a while I'm talking so you make sure you remember this. Great. So this chart exercise we're going to do together, we have to figure out on this first row here, what's the answer with units? I know we're all looking like, what? So the formula here is final velocity minus initial velocity over time. So you think to yourself, what formula is that? Acceleration, right? So here it looks like somebody did the work here, air quotes, someone did the work here, me. 400 kilometers per second minus 200 kilometers per second over 4 seconds. So if you will find that answer in units, I'll give you 10 seconds to figure that out. Super easy. Great. So if you think you got the right answer, keep it in your mind. But let's look at the second row. We don't have a formula here. So I want you to look at the equation and the units to try to figure out what formula and what we're trying to measure. So here we see 30 miles per hour south, right? This south looks really interesting, right? All right, so if we have that equation, we solved it. We got 30 miles per hour, or 30 m, stands for miles per hour south. Why is south looking so interesting to, well, it's looking interesting to me. It should be looking interesting to you as well. But why does that look so interesting? I know it has to do with direction. Then we talked about going down south. So maybe you I hope you're not traveling 30 miles per hour south, because that would take you forever to get there. But let's just say you were going 30 miles per hour south. Maybe you're on a moped or whatever, right? You're going south. So that has to do with direction. Which term or what's measured with distance, time, and direction? 10 seconds, 10 seconds. Great. Let's see if you're right. So here we know we were talking about on the top row, acceleration. I gave you that answer, or maybe you arrived at that answer, right? If you got 50 kilometers per second squared, amazing, did a great job. You have 400 minus 200, which is obviously 200, right? 200 divided by 4 is 50 kilometers per second squared. Please remember when you're looking at and dealing with acceleration, squared has to always be there or your answer is wrong. All right. So let's go down here. We were looking at south. South was looking real interesting to us because it had to do with direction, right? Doesn't velocity have to do with direction? So if you chose velocity, you're a genius. You figured it out. All right. So imagine if this south wasn't here. If this south wasn't here, what would we be referring to? Who has a similar formula as this? Speed, right? Great. So we know that velocity has to do with distance, time, and direction. Speed formula looks the same, but it just has to do with just distance and time. All right. Cute. And also remember, acceleration has to do with squared. Your units. Stop. Before we continue, it's time for some summarization, or basically your check for understanding, before we get ready for some more examples. So our check for understanding, while reading word problems, what word makes a velocity word problem more unique than a speed question? We literally just left this idea. Is it A, the mention of time that makes velocity so unique, the mention of displacement that makes velocity unique, or the mention of direction that makes velocity unique? Think about it. The units for acceleration are usually what? A squared or B cubed. That's my drum roll. If you pick C for direction making velocity word problem more unique, you are absolutely right. And for number 2, the units for acceleration are usually squared. These are 2 things that we just talked about. So if you feel like you didn't catch that, please rewind your video and take a look at them, please. All right, force. I know we're tired of it, but we're looking at force in a different light because now we're going to learn force's formula. So let's take a look at that. So first, we know that force is a push or pull on an object that causes it to be in motion. Like I said before when I was teaching Brown in Florida, when you guys decide to walk down the street, even though your parents say you can't go there, you walk down the street and go to the bodega and the door says, let's say, I've never been there, because let's say the door says pull, you're going to use your force to pull the door. Maybe it says push, you're going to use force to push the door. So there are different things that can cause force, not just you or wind can cause force. A bunch of different things can cause force. Even the gravity that pulls us to the ground, so we're not floating like we do in space because there's no gravity in space. Gravity is a force that keeps us grounded on the Earth's surface. Because if there's no gravity, we're in outer space and we're floating. So thank God for that force, because I don't want to be floating around. So let's look at the formula. Force is equal to mass times acceleration. Now we know that acceleration is just how fast or an object increases in acceleration, it increases in speed, right? Deceleration is the decrease of speed and velocity, right? So when something is accelerating, it's increasing in velocity, but it's also increasing in speed because it's covering distance and time, but it's also going in a given direction. So it's an increase in velocity and speed in the same thing, pretty much. Don't let that confuse you, because the only thing that's really different between speed and velocity are direction. So both speed and velocity are increasing, but the velocity specifically is increasing in a given direction. Now let's talk about mass, because only, and sadly, you know adults exist in the world too, only 2% of the world's population understands what mass is. You will be a part of the 2% once I finish this video. So you'll be a genius. So when we have that little elementary conversation about matter is anything that takes up space, blah, blah, blah. You know that, right? Anything that takes up space and has mass, right? So you're like, Ms. Reed, okay, matter, great. Matter is just telling us this book is made of matter, right? But this book also has mass, right? So mass is just the amount of particles or the amount of atoms that make something up. So if Ms. Reed is standing in, let's say I'm at the bank, and you see me standing next to someone who's much taller than me, they have more mass because they're made up of more particles than me, which is why they're so tall. They have to be made up of more particles, right? Now, if I start gaining some weight, right? I start increasing in mass. There's more particles that are made that I'm made up of. Now, our masses are the same no matter where we go. If I decide to become an astronaut and I go out of space, my mass is still the same, even though I weigh different. You know how they say on the moon you're lighter, and women are so excited about that. Ooh, I'm lighter, skinnier, thinner. No, ma'am, you are the same mass. You're made up of the same amount of particles. It's just if you stepped on a scale in outer space, you'd probably be like 16 pounds, 17 pounds, right? But here on Earth, you're like 120 pounds, 130 pounds, right? And the difference between weight and mass is that mass is always the same. Just because you're on the moon doesn't mean that some particles leave your body and your mass is less. No, you're made up of the same, unless you like cut your arm off or something. But at that point, yeah, you're losing particles, you're using mass, right? So let's get back into this. But I want you to understand the difference between mass. So mass is the amount of matter in an object or living thing, how many particles you're made up of, right? And then we know that acceleration is just the increase of a change of velocity over time. Now let's look at this, what is this called again? Formula. So the formula is mass times acceleration, but the units here are always Newton. Now, if you have more than one, which we usually do, you're going to put Newtons, obviously, ELA lesson, right? Or if you're just not the type of person that wants to write things out because you're super lazy, 28 N's, well, 28N, right? All right, great. So let's put this into play. Find force using the formula. We know what the formula looks like. I just dragged it, talking about mass and acceleration. You'll never forget. Ask yourself these questions. What is the criteria for success when handling these questions? You know that already because I've been drilling it in your head. How do I recognize acceleration within the word problem? And what are the units for force? So let's look at this. An object with a mass of 4 kilograms, that's what the kg stands for, is accelerating at, this is supposed to say 3 meters per second squared. Because we know acceleration has squared, that the units are squared usually. What is the net force on this object? Let's get it in. I know you guys are so mad, that's why I put this again. Annotate. The first step is to annotate. So we annotated 4.0 kilograms, right? Because that's our mass. And it's accelerating at 3.0 meters per second squared. Accelerating is right before this. So we know that this is for acceleration. And we also know that because the units are squared. Beautiful. Then we need to find the what? The net force on this object. What is the force being applied on this object? Choose your formula. If you know the question is calling for net force, you obviously need to use the force formula. So I wrote the force formula here. Force equals mass times acceleration. This is how you should be looking every time you figure out the formula. Like, oh, I know that answer. You know how y'all do that hand wave, that crazy hand wave, and then you get up, stand straight up, and you never get called? Yeah. Create the equation. Substitute those numbers in. Take the place of those numbers. So mass, we knew, was 4.0 kilograms. Put that right there. Times, what was our acceleration? 3.0 meters per second squared, of course, because those units have to do with, the squared units have to do with acceleration. So simply, you just substituted or took the place of mass by putting that mass, the number representing mass, which is 4 kilograms. And then you took the acceleration value, 3, and put it in the place for acceleration. Real simple substitution, right? Multiplication is easy too, so we can do that in our brain pretty quick. Answer in units, 12.0 newtons. Or like I said, if you don't want to write it out, I know a lot of my organized ladies like to write it like this, so I wrote it like that, but some of our guys in class, just 12 n's. That's it, 12 newtons. That's fine. As long as you're giving your answer with units. All right? If you're having trouble understanding this, please rewind and look over this again. Check for understanding, our favorite part. Force can be measured by using both what? What's included in the force formula? Is it A, mass and acceleration, mass and velocity, or weight and mass? What are the two things in that equation? I just dragged it earlier and we talked about it so long, so we should remember. Force is measured in A, pascals, B, newtons, or C, energy. We just did an example and we talked about it too, so you should have the right answers. Let's take a look. I'll give you 5 seconds. Perfect. Force can be measured by using mass and acceleration, because that's what's included in the formula. Force equals mass times acceleration. And then force is measured in newtons. Pascals is for something else, and energy is not a unit at all. Key points. We recognize what the questions were asking by looking at the work done to determine what the concepts or formula to use and that chart activity. We used the routine to solve our force and word problems. We were hypnotized, reminded, to use the routine for solving. That routine chart is helpful. And we showed step-by-step process of showing our work. That's everything that I want you to do and what I want you to tackle when you're looking at these word problems. Recognize what the question is asking, use the routine, annotate, select the formula, use the equation, give my answer in units, and show that step-by-step process. All right? Our favorite part, besides the check for understandings, navigate to Google Classroom to fill out your exit ticket and submit it before class ends. You have 5 to 6 minutes. Thank you so much. I hope you enjoyed the lesson. If there's anything that I can do to improve the lessons, please let me know. Via Google Classroom, send me an email, whatever is best for you. We're at home now with our parents, so we can definitely ask our parents, hey, can you give Miss Reed a call? So just give me a call. Also, there are other supporting teachers as well, Miss Wilson, Miss Johnson, Miss Vera. If you're comfortable with them, I'm happy if you're able to reach out to them too. So in any event, please reach out to your teachers. We're here for you. All right.